Okay, now let me give you a very general case. This is M1. This is M2. This angle is alpha. This angle is beta. Any general mass M1, M2, any general angle alpha, beta. Given that M2 is greater than M1, then we have to find what is the acceleration of the system. And this one you should get it right very quickly. Don't skip the problem. If you think it is easy, then solve it fast as you can. Now that you have learned it, generate speed. I'm giving you the answer, but you please try this. The acceleration would be M2 sine beta this is going to be the acceleration, and pretty simple to find this. This is the M2 sine beta minus M1 sine alpha upon M1 plus M2 into G. This is the acceleration of both. If M2 is greater than M1, suppose this is the acceleration of M2 down the plane, and this is the acceleration of M1 up the plane. Okay, just see if you're getting this. If you're getting this, very good. You are learning mechanics quite well. Okay, now let's solve one very interesting problem. This is suppose a lift, and there's a hole in the roof, and this wire is coming inside the lift, and there's a man inside holding the wire. Understood the situation? Now if he pulls on the rope, then he can climb on the rope together with the lift. If he pulls the rope downward, then this end will go upward. Along with it, the man can go upward. Right? So the question is, if the man is applying 400 Newton of force, and suppose the weight of the man is 50 kg and the weight of the lift is 25 kg, or let's suppose he's 60 kg and let's keep it 50 and 25. He's 50 kg, he's 25 kg, 400 Newton of force the man is applying on the rope. Then the question is, with what acceleration the lift will be going up, and along with him the man will be going up. So with what acceleration the system of lift and man will be going up. So this question present in the present form is rather on the easier side. You can get the answer very easily. Please try your hand on this and tell me what is the acceleration of the lift and the man system. The acceleration of the lift and the man system should come out as 2 by 3 meter per second square. If you got your answer right, you're doing pretty damn good. Let's discuss. For the lift and the man system, the external force is at this end and at this end. These two tension are the external force upward, and mg would be downward. That's the only force acting on the lift and the man system. So the 2t is upward and mg is downward. Mg would be 750 for both. This is the net force upward, and this should be equal to mass into acceleration. Mass of the system is 75. And acceleration would be, suppose we have to find that is a. Then acceleration comes out as 50 upon 75. That gives you 2 by 3 meter per second square. Not a problem? Easy. Now suppose the question is, how much force will he have to apply if the system have to move with a constant velocity of 1 meter per second? Interesting. 1 meter per second. The answer would be 375 Newton. And if you have got it right, you are doing very good, and you may skip the discussion for this. 375 Newton will be applied. You see, 1 meter per second is constant velocity. That means there is no acceleration. F is equal to ma. We believe in this. Now, if the body is moving with constant velocity, then there is no acceleration at all. This acceleration is 0. So the right hand side of the equation is 0. So the left hand side of the equation should be 0 as well. That means if a body is moving with constant acceleration, there is no force at all. So the net external force there has to be 0. So whether it moves with 1 meter per second, or it moves with 5 meter per second, or 10 meter per second, whatever speed it moves with, if that is remaining constant, then there is no acceleration, and then there would be no force, net external force. So all you have to do is make the net external force as 0. The net external force upward is 2t, downward is 750 Newton. This has to be 0. T would come out from here as 375 Newton. Done? Now let's move to a better problem now.